I'll show you a very quick way on how to do completing the square for any kind of quadratic that you might encounter, and then I'll show you a little formula at the end to help you remember it. So when you're doing completing the square, that is when you have a set of brackets and then you have some constant on the outside. So let me show you how you get this. Firstly, for the bracket that's going to be squared, all you do is you write x, and then it's just half of the coefficient of the x term. So in this case, the coefficient of the x term is -6, half that is -3. Then you're going to subtract that same coefficient squared. So we're going to subtract -3 squared, and then the number on the end, the constant on the end, just goes on the end as well. Then all you have to do is expand this, and there you go, completing the square, which is a grade 9 topic in GCSEs if you're doing GCSEs, but it's also very useful in all kinds of different maths. So let's go through a few other examples, and I'll do the next one a little bit slower. So again, you're going to put a set of brackets and you're going to put a squared around them. You're going to put an x in the front. Then all you're going to do is you're going to half the coefficient of x. The coefficient of x is 8, so if we half that we get 4. Then you're going to subtract the exact same coefficient squared again. So -4 squared, and then the number on the end just stays on the end, +5. So you get x plus 4 squared, -16 plus 5, so you get x plus 4 squared, -11. Not too bad. One more, again, maybe pause the video and have a go at doing it yourself. You have x plus 5, because again it's half of that coefficient, squared, minus the exact same coefficient again squared, and then the 2 is just on the end. Expand those brackets, and then simplify, and you're done. Nice and easy. Now there is one other type that's going to be a little bit trickier, which is what happens when there's a number in front of the x squared. Now, no matter what the number is, here's just a really handy trick for you. The way I do this is, all I do is I essentially divide through by 2, and then I times by 2 at the end. So the first thing we're going to do is we're going to divide everything by 2, and we're going to remember that for later, that we've divided by 2. If that was a 3x squared, you divide by 3. If it's a 4x squared, divide by 4, and so on. So that gives me x squared minus 6x plus, I'm just going to leave it as 23 over 2 for now. And now we do the exact same thing again. So we're going to put in brackets x minus 3 squared minus -3 squared plus 23 over 2. Let's expand that. Now I could combine the fraction now, or I could do something a bit clever. Because I've divided the whole thing by 2, my answer needs to be times by 2. So I'm just going to times by 2 now. That way I don't need to combine fractions. I can make my life a bit easier. So that becomes 2x minus 3 squared minus 18 plus 23. So we get 2x minus 3 squared plus 5. And again, that works regardless of whether it's 2x squared, 3x squared, minus x squared, minus 2x squared, whatever. You can just divide first and then times through on the end. Now I said that I'm going to show you a little equation that you can use to memorize this. Essentially all you're doing is, the general equation for a quadratic looks kind of like this, and here is the equation, right? Where b is the coefficient in front of x, so we've got b over 2 squared minus b over 2 squared, and then plus c on the end. Now the only other thing that they can ask you to do when it comes to completing the square is they can ask you for the minimum or maximum point of the graph. And so I'm going to show you how this works. So sometimes they might add a little y equals, because then it implies that it's an equation, that it's a graph, and you have to try and find the maximum or minimum point. How do you find that? Well, again, I'm going to show you the trick, and I might explain the maths at the end of the video. So the trick here is, you swap the sign of whatever's inside the bracket. So if it's a -3, it becomes a +3. And then the sign of the thing on the outside stays the exact same, so -8. So if I scroll down again, for this one, what would it be? Again, have a think for yourselves for a second. So again, you swap the sign of what's on the inside, so that becomes -4. And the thing on the outside stays the exact same. 2 more times. This one, again, have a think for yourself. Swap the sign of what's on the inside, keep the sign of what's on the outside. And lastly, for this one, this is what kind of confuses some people, is does it affect it when there's a 2 in front or a minus in front or a 3 or 5, whatever? The answer is no. You still take the opposite sign of what's on the inside. So instead of -3, it's +3. And the 5 stays the exact same. Now, for those of you that might want to know the reasons why, I want to explain the reasons why, but if not, hopefully that was useful to you. The reason for this is if we look at this graph here, if we want the maximum or minimum value, if I look at this equation, the only part that actually changes is x. So the only part that's actually varying here is the bracket squared. Now if I look at that, what is the biggest value it can be? Well, it can be anything, right? Because it's just a number squared, which can be anything, any positive number anyway. But if I have a look at this, what's the smallest it could possibly be? Well, the smallest it could be is, let's say it was a negative number. Let's say x was -2. -2 minus 3 is -5. Squared is 25, right? The other way you could do this, by the way, is you could actually sketch that part of the graph in order to find what the minimum point is. And you'll quickly find that the minimum point of this graph is actually 0. So, what does that mean? It means that this thing inside the brackets is always bigger than or equal to 0. Because again, if I sub in a positive number, I square it, it becomes positive. Sub in a negative number, square it becomes positive as well. So the smallest it can be is actually 0. And when does that happen? That happens when x equals 3, which if you notice, is the x coordinate of my turning point. Now, if x equals 3, what does the y value equal? Well, let's sub it in. 3 minus 3 is 0. 0 squared is 0. Minus 8 is -8. That's how you find the turning point as well, and that's the explanation behind it. Hopefully that makes completing the square a little bit easier for you. See you in the next one.